Previously, we learned how to simplify a rational expression and then how to multiply rational expressions. And we found that the process is very similar to simplifying a fraction and multiplying fractions or dividing fractions. So now we are going to look at how to add or subtract rational expressions. And again, we're going to compare the process to adding or subtracting fractions because they are also following the same steps. So recall that when we add fractions, the first thing we want to do is to find the least common denominator. So we need to make them match. If they don't match, we cannot add them. And so looking at 4 and 6, we realize the least common denominator is 12. And so you may be able to just see it if you have trouble seeing it, and you can break them down. 4 as 2 times 2 and 6 as 2 times 3. Create a new column for that, and then that's going to give us least common denominator. Bring down one number from each column. So 2 times 2 times 3, that's exactly 12. And if you can just see least common denominator is 12, you don't have to show all that work. And the second step is to equal the denominators. So the fractions we have, the first one is 3 over 4. But we don't need, we want to change the denominator 4 to a denominator 12, because that's the common denominator we're going to use. So in order to get 12, we can multiply the bottom 4 by 3 to get 12. And to keep the equivalent fraction, we need to also multiply the same number on the top. And for the second fraction, 1 over 6, in order to change 6 to 12, we can multiply both top and the bottom by 2. So now we have the common denominator, which is 12. But the top, we have 9 over 12 and a 2 over 12. So now we can keep the common denominator 12 and add the numerators. 9 plus 2 gives us 11. So that's how we added fractions. Now to add rational expressions, we are going to follow the same steps. First, we found the LCD. So in this case, we have 3, 4, 3, 6. Again, the LCD is also 12 because 4 goes into 12, 3 goes into 12, and 6 goes into 12. And 12 is the smallest. And usually we recommend that you use the least common denominator. I know some students might just multiply the first fraction, top and the bottom, by 6, and the second one by 4. If you do that, that is okay. Without finding the least common denominator, what you used, 4 times 6 is 24. 24 actually is just called a CD, common denominator, but not the least. Usually we recommend that you use the least because the fraction, you don't have to simplify too much. If you use 24, you got to make sure in the final step your fraction is reduced. So you would definitely have to reduce the fraction. And so that's something that can work, but we don't recommend that. And the same thing here, if you didn't use 12, you multiply all three numbers, and that's going to give you 72, which is much bigger than the LCD. All right, so now we're going to do the second step, equal the denominators. The first one we have, let's copy down the first fraction. Notice the top has 2 terms. So when we multiply the bottom by 3, we got to make sure you multiply both of them by 3. So you want to multiply the entire top by 3, which means we should put parentheses for the top. And that will remind us that we have to distribute that 3 to both of them. So similarly, for the second fraction we have, what we call it a rational expression, we multiply both top and the bottom by 4 in order to get 12. Again, I use parentheses for x minus 1 to remind myself that I have to multiply both of them, both terms in the numerator by 4. And the third rational expression is x minus 4 over 6, and we again multiply top and the bottom by 2. And next part is we're going to work them out. So the bottom we have 12, and top distribute 3 to both terms. So we get 3x plus 6. And in the second fraction, we have distributed 4 to both of them. So we have 4x minus 4 over 12. And the last one we have distributed 2 to both of them. So we have 2x minus 8. And after that, we follow the third step, keep the common denominator 12, and add or subtract the numerators. I'm going to slow down here a little bit. You might be able to skip this step later, but I want you to see that I put a parenthesis for every top, because the top has 2 terms, and you got to consider it as both terms as the top. For addition, usually it doesn't matter whether you put parentheses or not, but for subtraction, if we didn't have parentheses here, you will be doing minus 2x minus 8. But if you put them in the parentheses, notice that after you distribute a subtraction sign, this negative 8 will become a positive 8, because negative times negative is positive. And so it is important to keep a parenthesis there. So and it doesn't hurt to have put the top 2 terms in the parentheses, and sometimes might be redundant, but you won't make any mistakes, because if you forget the parentheses and it's subtraction, you could have opposite sign here. Again, the reason is this minus is subtracting the whole top, both of them, not just subtracting 2x. So this minus needs to be distributed, because plus it doesn't change any signs, but a minus could change all the signs. Okay, so now we're gonna the top is something we discussed before the first exams. We had similar questions like this. We did similar questions before. So when you distribute a negative sign to what's in the parentheses, negative times negative will become a positive. So this plus sign right here, we need to be very careful. So it's a common mistake that a lot of students forgot to distribute this minus sign to that, because it's minus 8, which makes it a positive 8. So after that, we can simplify, combine all the like terms. 3 plus 4 minus 2, that's going to be 5x. And 6 minus 4 is 2. 2 plus 8, that's a 10. And notice this fraction, this rational expression is already simplified. The top, we may be able to factor out a 5 to get x plus 2, but 5 does not have anything common with 12. So we don't need to do that step here. The reason we're doing factoring is we can cancel something common, but after we did the factoring, we didn't find anything common. That means, that factoring is not necessary. So you can just leave the answer as 5x plus 10 over 12. Now, then we can look at another example. And this example just shows us that the process of addition is adding rational expressions is very similar to adding fractions. And the next step will be the next type question. We will have variables in the denominators, because in the first example we didn't have any variables, 4, 3, 6. So the process of finding the LCD is the same as adding fractions. But what if we have variables in the denominator? So in these two examples, as you can see, we have n squared, 3n variables in the denominator, and or a squared, b squared. So how do we find, the first step will still be the same, finding the LCD. But the process of finding LCD is going to be the same as we did before. Whenever we look for the LCD, we can factor, as we just did here. So just in case you didn't know how to find the 12, we could break down 4 as 2 times 2, break down 6 as 2 times 3, and line up the same number and pick one number from each column. So we can follow exactly the same steps. So what we do is we break down n squared as n times n, and we break down 3n as 3 times n. I can line up the n with the first n we see, and the 3 create a new column for that. And number 2, notice that there's no 2 yet. There's not a column for 2, so let's create another column for 2. So we're doing exactly the same thing. We're just factoring each one out. Factoring again means what times what will give you n squared. So that's apparently n times n. So now we can write down the LCD, which is what we call LCM before, least common multiple. D represents denominator because all of these three are denominators of those rational expressions. So now we can bring one from each column. So let's bring down n, and then bring down another n, bring down a 3, and bring down a 2, and multiply all of them together. That gives us 2 times 3 is 6, n times n is n squared. So that gives us the least common denominator, 6n squared. So that's something a little bit new. The process is, we did this process before to find LCM, factoring each of the denominators and line up the same number or variable. So the only thing new is we may have variables as factors. But other than that, it's the same process. Okay, there's a different way to look for the LCD. You can look at the numbers 2 and 3. The LCM is 6, so you can get 6 immediately. And n squared n, you actually take the highest power. So previously, when we discussed factoring, we have a GCF type. When we have variables, we always take the lowest one, because n squared and n, they have n in common. They don't have n squared in common. But for at least common multiple, you would take the one with the bigger power, largest exponent, because LCM is the opposite. It's that we need to make sure everything goes in there, and apparently n goes into n squared. But if you take the lower one, if you take 6n, n squared doesn't go into n. And so that's why LCM, we got to take the larger one. Okay, so after we found the LCM, now we can equal the denominators and follow the same step. So we got to change all the denominators to the LCD we found, which is 6n squared. I'm going to go ahead and write down all three of them, 6n squared. Okay, so now let's work out one by one. So the first one, in order to get 6n squared, we can multiply both top and the bottom by 6, because 6n squared, the bottom will give us what we need, and the top is going to be 30. The second one, in order to get 6, we multiply by a 2, because 2 times 3 is 6. And in order to get n squared, we only have an n. Let's multiply another n, because n times n will give us n squared. So the top, 2 times 2n, that gives us 4n. And similarly, for the last one will be to get 6, we multiply by 2. In order to get n squared, we multiply by n squared. So both the top and the bottom, we multiply by 3n squared. And now we can keep the least common denominator 6n squared and add or subtract the numerators. We have 30 minus 4n plus 3n squared. And notice this is already the simplest form because there's not any number in common. If you look at the 6, then the only number that can go into 6 would be 2 and 3. And but 2 does not go into 3. And also 3 can go into 3 and 30, but 3 doesn't go into 4. So there's not a GCF. And similarly, n doesn't go into doesn't go into 30. So although these two contain n, but 30 doesn't have n. So this would be our final answer, the simplified form.